In our last video, we saw how to use the pygame transform module to create some simple sprite animation, plus other effects. In this video, we're going to level it up with sprite sheet animation. This video should stand alone, so don't worry if you haven't watched the whole series. However, you should have some rudimentary knowledge of the game loop and surfaces to get the most out of this video. Let's get started. I've downloaded a sprite sheet from opengameart.org and modified it slightly. There's a link in the description. Maybe you have your own sprite sheet. We're going to look at a couple of different ways to use pygame surfaces, the drawing canvases in pygame, to animate a sprite from a sprite sheet. The first thing you need to know is the size of your sprite, the number of frames, and where the different frames are in your sprite sheet. Let's use this blue fish sprite in the upper left of the sprite sheet. I didn't draw this, so I need to measure it. In Photoshop, I'm opening the Info window, and I want the measurement set to pixels because that's the measurement I'll be using in pygame. The first frame appears to be 32 pixels wide by 32 pixels high, and I can draw the same sized rectangle around the other 3 frames. We'll try animating it and see if it looks natural. I have a little test program here. This program draws a window and waits for the user to quit. While waiting, it animates a sprite moving down the screen, and that's the part we're interested in. Before adding animation, all this code does is move a sprite down the screen. We do that by having x, y coordinates for blitting the sprite, which I start out at the middle top of the screen, and a sprite dy variable, which is the amount the sprite should move each time through the game loop. I've set that to 5. Each time through the game loop, we add 5 to the y coordinate and then blit the background to clear the screen, and then blit the sprite over the background. That will make the sprite appear to move down. Now, for the animation part, we want that to be a little slower, so I have a counter. Once that counter reaches 10, I use a different frame from the sprite sheet. Let's see how we do that. The blit method is the surface method we use to copy pixels from one surface to another surface. In the past, we've just used the first 2 parameters, as in the line of code screen.blit background 0, 0. We send the message to the surface we want to copy to. Here, I'm copying pixels from the background surface to the screen. The second argument is the coordinates on the screen that will be the upper left of the pixels I'm copying. So because I want the whole background to cover the screen, I'm blitting to the top left, 0, 0. But there is an optional third parameter, which is called area, and that allows us to select a rectangle out of the surface we're copying from. That is what we'll use to select the next frame from the sprite sheet to copy to the screen. We can define a rectangle as a tuple of x, y, width, height. The width and height are constant. Remember, our sprite is 32 by 32, so I've defined constants for those. I've called the x and y coordinates of the frame in the sprite sheet, sheet x and sheet y, and I've initialized both to 0. The y is always going to be 0 because our frames are located along the top of the sprite sheet, but x will need to change. The first time we change the sprite, we want to grab the rectangle at 32, 0, and the next time we change the sprite, we want to grab the rectangle at 64, 0, and the last time add another 32 to that, giving us 96, 0. So we can add the width of the sprite to the current sheet x each time, and we'll get the location of the next sprite. That works until we advance past the last frame, and we need to go back to the frame located at 0, 0. I've set a constant, num sprites, to 4. We could use an if statement to check if our sheet x is equal to sprite width times num sprites, and if so, set sheet x back to 0, and if not, set it to sheet x plus sprite width. That would be fine. But this is a perfect application for mod. Mod is great for wrapping around operations like this. When we repeatedly add and mod by a fixed value, the result wraps back to 0 once it reaches the modulus. I have a whole video on applications of mod, including a detailed explanation of using mod with a sprite sheet, if you're interested. Here I'm using mod to calculate the x coordinate of the next frame. I'm doing it by adding the width of the sprite to the current x coordinate, and modding by the width of the strip of frames. So I'm calculating 0, 32, 64, 96. You could also use mod to calculate the number of the next frame, so 0, 1, 2, 3, and then multiply that by the sprite width, again giving you 0, 32, 64, 96. Repeat. When we run it, You can see that works just fine. The fish moves down the screen, animating as it moves. We could use mod to adjust the coordinate back to the top of the screen once we reach the bottom, too. Pause the video and see if you can change the line of code y plus equals sprite dy so that the fish wraps back to the top of the screen. How did that work? Did you remember to adjust for the sprite's height as well? My code is y equals, in parens, y plus sprite dy, mod, in parens, window size plus sprite height. Before we look at another surface method we can use with a sprite sheet, let's incorporate this into our game, so we're animating a pygame sprite rather than simply blitting a surface to the screen. In our game, droppables are sprites that drop from bricks when they're smashed, so we'll subclass droppable and call our sprite animated droppable. I'm going to copy transform droppable because that already has the update timer as part of the sprite. We'll give our animated droppable a field called sprite sheet, which will be the surface that's passed in as the image to the initializer. And to keep this simple, we'll assume a 32 pixel size and a 4-frame animation, and I'll make those fields. We'll assume sheet y is always 0, but we'll have a field sheet x, which we'll initialize to 0. Now, image is the whole sprite sheet, so let's set image to the first frame, and then invoke the superclass init. The superclass init method will set the sprite's image, rect, and mask, so we want to give it the correct image to do that work. To make that image from the sprite sheet, we'll create a surface that is the size of 1 frame, and then set the area to copy from the sprite sheet to sheet x, 0, sprite size, and blit that over. That's just what we did in the test program. Then down in update, we'll recalculate the sheet x field when the timer tells us to, and repeat the blitting code and creating the mask. Now let's add an animated sprite to the droppable factory. I'll call it fish, and its callable is animated droppable. Its image is the sprite sheet, and I'm going to give it the coin sound, and that's all we have to do to add it to the game. Now let's look at another surface method that we can use with a sprite sheet. The subsurface method creates a new surface that references another surface. The two surfaces share pixels. To use this, I'm going to comment out the code in init where I create a new surface and blit, and I'm going to replace it with image equals self.spritesheet.subsurface, so that is the surface that contains all of the sprites, and then the only argument is the rectangle that I want for the new surface, the rectangle of the first frame. I'll pass in the same rectangle from our blitting code, sheet x, 0, and then the width and height of the sprite. And I'll do the same in update, just subsurface the sprite sheet for the image. We already calculated the rectangle. This method can reduce memory usage because each animated droppable references the pixels of the original sprite sheet instead of creating a separate copy of the frame. Whether it's actually faster depends on your game. Creating subsurfaces still creates surface objects, and for small sprite sheets, the performance difference is usually negligible. So, that is your guide to animating a sprite from a sprite sheet. For homework, find a sprite sheet online or create your own, and make your own animated droppable. You could also create a sprite that walks across the bottom of the screen or flies through the center of the screen periodically, just for fun, or as a chaotic element if you wanted to incorporate it into your collision detection with the ball and other droppables. If you get stuck or want to share your successes, drop a comment below. And as always, have fun and keep coding.